Alright class, this is actually a video for both day 1 and day 2 of 4.6, so you could do that all as one day. We just kind of split it up so that the second day there's a lot of review time. So first thing I want to talk about is just how to solve log equations and exponential equations. We actually talked about this in the last video. If they're log equations, you want to condense both sides to one log, so you should have only one log on each side. Sometimes there might only be one log on one side and a number. If it's just one log on one side and then a number on the other, you want to rewrite it as an exponential to solve. If there's a log on both sides of the equation, you can cancel the logs and then solve. When you get an answer, you must check it within the original problem to make sure it fits within the domain. That is critical. For exponential equations, you want to either natural log or log both sides, because you can use your calculator for those. And then that'll let you bring down the exponents. When you do that, you have to distribute if necessary, group x's together if there's more than one x, and then factor and solve. So pause the screen or write all this down, and then we will go on and just solve some equations today. Okay, this is not working. 1 second. There it goes. Okay. So first thing you have to do is we need to condense it to one log on each side. This one has two of them, so we're going to use the property of when you have two logs added together, you multiply the numbers. So we get log base 5 of 2x plus 3 equals log base 5 of 3 times 2. Now we have log base 5 on both sides, and we can cancel it because it's doing the same thing to both sides. You could also think of it as we have 5 to all this stuff and 5 to all this stuff, because 5 will cancel out log base 5. Some of you guys learned it that way as well. So you get 2x plus 3 equals 6. 2x equals 3, because when you subtract 3, x equals 3 over 2. Now we have to plug this back in to this, and this needs to be greater than 0 always. If I put 3 halves in there, it will be positive, so that works. So that is our answer. Here we only have a log on one side, so we want to rewrite it in exponential form. So 5 squared equals 2x plus 3. Now we solve, we subtract 3, and we get 2x equals 22. Divide by 2, we get x equals 11. Plug this into this again, and sure enough, that's going to be positive, so we're good. Next one, we have only log on one side. So we have to condense this by multiplying these pieces together. So when you multiply those pieces together, you get log base 4 of x squared plus 3x equals 1. Now we have to write it as an exponential. So it's 4 to the first equals x squared plus 3x. And now we move the 4 over. Because we have a quadratic, we want to set it equal to 0. And there it is. And then with quadratics, most of the time I will give you ones that factor. So hopefully you guys can factor this. Two numbers that multiply to -4 are 4 and 1. The -1, positive 4. That adds to 3 as well. So we put x's in front of these. And then we set each equal to 0. And you get -4 and 1. But be careful. If you put this -4 into here, you have a negative value for both of these. So -4 doesn't work. It's not in the domain. However, 1 is fine. So 1 is the only answer for this problem. Alright, this last one, there are logs on both sides, and there's only one log on both sides. But before you can condense or cancel, the numbers in front of the logs have to be gone. So this has to be x cubed instead. So I do that, and now I can get rid of the logs. And I'm left with x cubed equals 27. And you guys should know that what cubed is 27? That would be just 3. And then 3 works in there because it's positive. So that's how you solve log equations. Either condense and then rewrite it, or condense and cancel logs. Now we're going to do exponential. Now the nice thing about this is you do not need to check answers for domain, because The domain for exponentials are all real numbers always, so there's no restrictions. Alright, so let's take a look at how this works. I want to get this x down from up there, so I need logs, or natural logs. I like using natural logs because it's 2 letters. So I'm going to say, well, if this equals this, then the natural log of this equals the natural log of this. And the reason we can write that is because we were just doing the same thing to both sides. That's one of the properties. And now I can bring the x down here. Okay? So then finally I could say x is equal to, and then you can divide by natural log of 3. So we get natural log of 14 divided by natural log of 3. So that would be the exact answer. Now, you could also type this into your calculator to get the approximate answer. And if you type this into your calculator, and you guys want to check this, natural log of 14 divided by natural log of 3 should give you approximately 2.402. Now, if I said leave it as exact, I'd want this answer, but if I say round it to 3, I want that answer. This is the more tricky one. So, same thing, first thing we're going to do is natural log both sides so that this comes down. But notice how this side has a lot of stuff that comes down. So here's what happens. We get x times the natural log of 2. Then on this side, so that's x times a number, equals, I have 1 minus 2x times the natural log of 5. So the natural log of 5 and the natural log of 2 are numbers. So this is like saying I have a 5 out here, or a 2. To solve this for x, I'd first need to distribute this number into both things. So over here I still have x natural log of 2. Here I have 1 times natural log of 5, which is natural log of 5, minus 2x times natural log of 5. You cannot multiply the 5 and the 2. Natural log of 5 is its own number. You have to think of it as that. So it's just 2x natural log of 5. Now remember, once you distribute, the next thing you do is we have to solve for x. But we have an x on both sides. So you need to get all the x's to one side. So I'm going to move this piece by adding it over to here. So I end up with x natural log of 2 plus 2x natural log of 5 equals natural log of 5. The whole reason we do that is now, notice how both of these pieces have an x in them. I can factor the x out. So I'm going to factor the x out, x. And what that does is remove the x from that natural log of 2 and removes the x from the 2 natural log of 5. Now, I have x by itself. I can divide by this whole thing. I'm going to just divide by this chunk. So my final answer is x is equal to the natural log of 5 over the natural log of 2 plus 2 natural log of 5. That is the exact answer. So if I ask for the exact answer, you can just leave it like that. If I do ask for a non-exact answer, or the rounded answer, you can type this in your calculator carefully. And if you do that correctly, you should get that that's approximately 0.411. So you could try that on at home if you want to see if you can get those right. Okay? Alright, that's it. That is exponential and log solving. So I will see you guys later.